All right, so we're going to do another example problem here. This time, another circuit with two sources. And the question is asking us to determine all the voltages that I labeled in the circuit, basically in blue. And so we can take a couple of different approaches here. I'm going to go ahead and take the superposition approach just to give another example of solving a problem using superposition. And so what I'm going to do first is I'll just draw the two circuits that we need to solve in order to solve the main circuit, right? We need to solve it once without the current source and once without the voltage source. So first I'll remove the current source, and that circuit will look like this, right? I'll have no resistor or no current source there. And then this is what the rest of my circuit will look like. Just like that. Right, and then in the second case, so this is going to be R1, R2, R3, and R4. This will be my V1. And then, of course, this would be VW1, VX1, VY1, and VZ1. All right. And then the second case would be with no voltage source. So I would have my current source here. That's going to be I1. I'd still have my resistor there, resistor here, and then where the voltage source is, there would be a short. All right, so this is my two equivalent circuits. I've got R1, R2, R3, and R4. And in this case, I've got VZ2, VY2, VX2, and VW2. And then, of course, we know that VW final, basically, this VW is just going to be the sum of VW1 and VW2, and the same for VX with VX2 and VX1 and VX2, and so on. So let's just write that out. Of course, we should know this by now, but that's what examples are for. All right. So this is how we're going to go about solving the problem using superposition. I have another slide here. So let me just copy. I'm going to copy everything I need, which is basically all of this. And then we'll just use it over here. Let's go ahead and put one of these over here and the other one over here. Oops. And we can go, if this video starts to get a little bit long, then I'm not opposed to just starting, I'm not opposed to just starting a second video here to solve this example. And then the last thing I'm obviously going to need are my values. So let's bring those on over with us too. I'll just throw those up here in the corner. All right, so let's do this. Let's start with the first one. If the video gets long, we'll just stop it. But so let's start with this circuit right here. Really, if you look at it, it might initially look like a two-loop circuit, but it's really just a single loop where this is my ground. I have a voltage source and a couple resistors in series. And then because this connection here is broken when the current source comes out, I don't have any current that flows in these two in this branch of the circuit, basically. Since I have no current flowing here, then I have to have no current flowing here too, right? So then the voltage drop across R1 is equal to I times R. Well, that I is 0, so this has to be 0, right? So right off the bat, I can see that VW1 is going to be 0. And also, hopefully right off the bat, you can notice that I just have a ground connected to a minus terminal of a battery. So then the plus terminal, of course, is just going to be the rating of my battery, which in this case is 24 volts. All right, so that's going to give me VZ1. And now we just need to solve for VX1 and VY1. And this is sort of tailor-made for just a quick KVL loop around this circuit here. I'll call this I. I guess I can call it I1. But if I do just a quick KVL around, you could also solve it using a voltage divider if you wanted to, by combining any combination of these resistors and solving for the first voltage, and then you know, then solving for the current, but we'll just go for it all in one shot with KVL to get the current right off the bat. So what I'm going to do is I'll label my plus minuses across my resistors in the direction of my current. And let's write a quick KVL loop. So it's going to be that V1, right? I'm going this way, starting here, and I'm going this way. I'm going up across V1, right? So that's going to be V1. Then I'm going to drop across R4. So it's going to be minus I1 times R4. Then I'm going to drop across R3, and I'm going to drop across R2. And I set that whole thing equal to 0. Clearly, I can just say minus I1 times R2 plus R3 plus R4 because they're all in series. And then that gives me that V1 is basically equal to I1 times R2 plus R3 plus R4. Again, the goal is to find I1 here. So I1 is going to be V1, which is 24 volts, divided by the sum of R2, R3, and R4, which looks to me like that's going to add up to 20K. Okay, let me do the math real quick. I think it should be something like 1.2. Is that just 1.2? Yeah. 1.2 milliamps sounds right. I'm doing mental math, so hopefully I don't make a mistake there. But now that I know I1, I know that's 1.2 milliamps. You know what? Let me get my calculator. I don't want to make an error and then have to redo this. Okay, so let's go ahead and move these values here that we found right off the bat, and then I'll just move this whole thing up so that we have more space. Okay, because I'm running out of room here. Let's just make sure 24 divided by 20K. Yep, that gives me 1.2 milliamps. And now that I know my current, again, I can find my drops. So across R4, the voltage drop is basically going to be R4, which is 2K, times 1.2 milliamps. So the voltage drop across R4 is equal to 1.2 milliamps times 2K, which is 2.4 volts. So then that means that I know VY1, I guess I can write that in blue. VY1 is basically going to be VZ1 minus that voltage drop, right? I'm going from VZ1, I'm dropping across R4, so this voltage drop here that I just calculated gets subtracted from my 24 volts, and I should get VY1 to be 21.6 volts. Okay, and then the last thing is going to be to find VX, which is, or VX1, which is just going to come from the drop across R3. So my voltage drop across R3 is going to be 1.2 milliamps times 10K, which gives me 12 volts. And so all I have to do is subtract 12 volts from VY1, and I get 9.6. All right, so that's the first part of the problem. I basically solved for all of my voltages there for the first case in my superposition. In the next video, I'll go ahead and solve for this other circuit here, get the VX2, VY2, VZ2, VW2, and then we'll add them up, and that will be our final answer. Okay, so I'm gonna go ahead and end this video right here.